SQL Server 2008 Performance. When I was in high school, I was on the track team. When the track season first started, I was pretty slow, and eventually with practice I got faster. The only way to really know how fast I was by looking at my time. Well, with SQL Server, we have these things called performance counters, but we're not just measuring time of queries, we're measuring other things as well. With performance counters, we can determine the server activity as well as disk usage and query stats. Well, SQL Server 2008 came out with this thing called the MDW, or Management Data Warehouse. It's a way of collecting this kind of data and putting it into a special database dedicated to just that. In this nugget, I'll also show you how to create your own custom data collection so you can measure other performance counters besides just those three. Some of those performance counters include searching for full table scans, looking at log growth, and looking at user connections and transactions. Then we'll take a look at this thing called the Resource Governor, which is new to SQL Server 2008. It's a way that we can take different sessions coming into the system and assigning it to a workload group. Once it's in a workload group, the workload group is then assigned to a resource pool, which defines how much CPU usage we can have as well as memory. And then the last thing we'll do is take a look at monitoring. There's a couple performance counters in particular that are geared towards the Resource Governor. Let's get started with our performance counters and management data warehouse. Now I have SQL Server Management Studio opened up here, and I'm logged in as the SQL Server user of Julie 1. What I'd like to do is monitor activity on my databases, and so I need to collect that information into a separate database. This is called the Management Data Warehouse, and typically in a production environment, since it does involve a little bit more overhead, you would want to have your MDW database on a separate database from your production machines. But for this example here, I'm going to have everything on the same machine. So I'm going to first of all expand my databases. And I'm just going to right click on there and say New Database, and we'll call this MDW. I'll stick with the default attributes for all the other stuff. Now that I have that database right there, I can expand my management, and there's my data collection right there. I can right click on it, and I'm going to say Configure Management Data Warehouse. Essentially, this is going to associate MDW with the database that I just created. So make sure you have this first radio button selected, Create or Upgrade a Management Data Warehouse. Then we hit Next. The server name, put that in the first box there, and the database name is that database that we just created, and we hit Next. So at this point here, we can specify which users and groups have access to the database role membership for MDW. For example, if I want to make the Windows user of Julie have the admin privileges, I can do that. I can scroll down a little bit further. Okay. So now I can hit Next and then Finish. Everything was successful. Hit Close. You can hit your refresh button. If you expand your data collection right here, nothing shows up underneath it yet. We can right click on here now, and once again say Configure Management Data Warehouse, and this time we're going to set up a data collection. So this configures this instance to start collecting data to an existing Management Data Warehouse. So we hit Next. So I'm just going to hit this ellipsis right here. Server name is Julie 1. We're going to use SQL Server Authentication. Type in the password. And now under the database name, that shows up in the dropdown. Now, the MDW is going to involve a caching area. You can specify the cache directory. If you don't put anything in there, it will use the temp directory. I'm just going to leave that blank. And we'll hit Next and then Finish. So we're enabling our data collection. This sometimes takes a few seconds. And now we can hit Close. So now, when we expand our data collection right here, you'll see that you can expand the system data collection sets, and we have out of the box three types of collection sets. So now what you can do, like for example this disk usage, right click on here and you can look at the properties. And under properties you can specify whether these reports are collected every 6 hours, or you can also specify that you want to do this on demand. You can also choose to use cached instead of non-cached. The collection frequency here is every 60 seconds, at least for the disk usage. I'm going to scroll this up a little bit. You can also determine how this is run as SQL Server Agent Service account. So for this to work, you do need to make sure that your SQL Server Agent Service is actually up and running. You go to that by going to Administrative Tools, then Services, and you can also specify how long you're going to retain this data. You can specify indefinitely if you want to, but be careful about disk usage there. And one side note that I'd like to make as far as this non-cached property here, you'll see that you have two choices, on demand or a given schedule. Right now we have this configured to be on a schedule of every 6 hours. If we say on demand, then what you're going to have to do is right click on the disk usage and stop and start the collection. Let me show you what I'm talking about. Okay, so if I right click on disk usage right here, I can then say stop data collection set, and then I can restart it, or I can collect and upload right now. So you have different options there. For right now I'm going to leave it alone. Once we have some data collected, we want to view the reports. Now if you're using these three out-of-the-box data collection sets, then you can simply right click on data collection, go to reports, and then go to Management Data Warehouse, and you can look at the different histories. For example, if we want to look at our server activity history, we can open that up and we'll see all sorts of charts and graphs. It might take a few seconds for it to retrieve data. And here is our report. Okay, so we have our server activity history. It tells us the timestamp. So here you can click on any of these timestamps to see what the activity looked like. For example, percent CPU usage, memory usage, disk I/O usage, and so on. And then we can look at our SQL Server weights. And so you can see if there's any spikes in activity. So you'll see that there's no data here, and that's because we started the data collection right here at this point in time. We can also see the SQL Server activity. Okay, so we can see, for example, batch requests, logins, logouts, transactions, user connections, and so on. Any types of spikes of activity you can graphically see. Now you can collect your own data as well. You can have your own custom data collection, but there won't be any corresponding reports like this out of the box. You're actually going to have to create your own custom report based on the underlying data. Now to create our own custom data collection, we'll want to, let's just X out of here real quickly and pull this over here. We want to get into our MSDB database, because that contains the API for our custom data collection. So we'll just say use MSDB and execute that. And next we want to create a collection set. Now a collection set just consists of one or more collection items. Okay, so the way we do that, there's a built-in API for this and it belongs in the MSDB database. So what I'm going to do here is I'm declaring two variables. One is our collection set ID, which is an int, and the other is collection set user ID, which is a unique identifier. It kind of looks like a cryptic string. The built-in procedure that we have here is sp syscollector create collection set. We have a corresponding delete collection set as well if you want to get rid of any of them. Okay, so here we give it a name. This will appear in the meta information. I'll show you that in a moment. So we'll just give this a name of disk performance. And for the description, this is going to collect logical disk performance counters. Our target, we're not setting that right now. We're not providing any logging either. This will expire in 10 days. We're not dealing with the proxy. This will be collecting every 5 minutes, and then these two are just output parameters. We're setting those variables that we declared a minute ago. So once we create that, then we can select from those two variables just to make sure they were set. So I'm going to hit execute right there, and that created an ID of 6, and there's the unique identifier. So now if I want to do a select star from sys collection sets, you can see that I've got disk usage, server activity, and query stats, which were from earlier, and then we have disk performance, which is our customized one. You'll see that under is system, all these are true, whereas this one it's custom, so therefore it shows right there. Also, we also understand that it is not running yet. That's why there's a 0 there. Now the next thing I'm going to do is create a collection item to go into my collection set. Okay, so I'm just going to go down here and let me scroll up a little bit. We're starting right up here with this declare statement. We're declaring a collector type UID3. It's just a unique identifier, and all we're doing is getting the unique identifier from the syscollector collector types, where the name is performance counters collector type. So there's a built-in performance counters collector type that has a corresponding UID. So that's all we're extracting here. This next line that we're on, declare collection item ID 4, that's going to be an int. That will be populated as an output parameter when we execute this create collection item. So create collection item, this procedure right here, takes several parameters. It takes a name. So in our case, we'll call this logical disk collection. It also takes parameters in XML format. So here we're collecting information such as the logical disk read and write, the number of bytes per read and write, as well as disk seconds for the reads and writes, and so on. We're just grabbing disk information. The other thing we're doing right here, the line that I'm on, this is setting the output parameter, so we obtain a collection item ID for that item. Frequency equals 5 just means collect that information every 5 seconds. And then we're passing in the ID for the collection set. So once you execute that, you can then select the collection item ID to see what that unique identifier is for the item. So I'm just going to highlight what we just put in here right quickly. Highlight that, and then I will execute it. So it gave me a little error here saying that we need to declare the scalar variable of collect set ID 1. What we can do here is actually issue this statement again to obtain that information. Okay, so this is our set that we created, and the ID is 6, so we can just directly plug that in. Let's scroll down here a little bit. Okay, so now let's re-execute this again. Okay, so there it is right now. So the item is number 6. So now, if we do a select statement, we can just go down here and say select star from sys collector, and let's look at the collection items. Here we have the logical disk collection that we just created. See here, the frequency is every 5 seconds, and so on. You can even click on this to see the XML for the parameters. In the example that we just did, we just used a handful of the performance counters. Now there's a whole slew of performance counters that you can choose from, and what I've got here are some of the more common ones that we look for. For example, if you want to see issues with your indexes, you can look at your SQL Server access methods full scans per second. That's going to tell us how many full table scans there are per second, and if that number is high, high meaning more than 1 or 2, then you'll want to look into adding more indexes. The second performance counter, the table lock escalations per second. You want to keep this number as low as possible. It just shows us how many table locks there are. So once again, this is related to your indexes. We have a couple more dealing with our buffer manager. The first one is the buffer cache hit ratio. In an OLTP environment, you want that to be 90% or higher. In a data warehousing environment, it will probably be a little bit lower. We have database pages. If this counter has high increases, it probably means that we need to increase the memory. For our SQL Server databases active transactions, that just tells us how many active transactions there are. This is one of those counters that, a particular number doesn't mean that it's too high, but you might want to see where there are spikes in activity. We have log growths. This has to do with the log files. If this number is increasing very quickly, you might want to consider increasing the log size. Transactions per second. For this one, you might want to see where the spike activity is and look at your applications and see if that corresponds, see if that's normal. We can look at the user connections. You might have an application that is constantly creating user connections, and if that's pounding the system, you might want to consider pooling those together. We have lock requests per second. This is another performance counter that you just want to see where the spikes are. In a data warehousing environment, a lot of times you want to make your environment read-only, so this number should be very low. The average wait time tells us in milliseconds how long it took to acquire a lock, so you want this to be as low as possible. Also, we have the number of deadlocks per second. You want that to be as low as possible. It just tells us the number of locks that resulted in a deadlock. And then we have SQL statistics, SQL compilations per second. You want this number to be pretty low as well, and you want to look for spikes in activity. So this is not a complete list of the performance counters, but these are the most common ones that we use. So in our data collector, for our parameters, that XML parameter, you would include whichever performance counters you want to. Well, that pretty much wraps up our performance counters and our data collection. Let's talk about our resource governor. Resource Governor is new to SQL Server 2008, and essentially it allows us to map different work groups to resource pools. So we'll talk about these different concepts and how to classify different sessions. Resource Governor also has some monitoring to see what the workload looks like for particular groups. I want to talk about the basic concepts of our Resource Governor. So as I mentioned, the Resource Governor is used to fix things such as runaway queries. It can prevent sessions from consuming too many resources. It eliminates unpredictable workload execution, and it can also let you set workload priorities. So with our Resource Governor, it's going to allow you to classify your incoming connections, and then you're going to route it to the appropriate workload group. You're going to be defining pool resources, and you can set the limits such as memory and CPU. What's also nice about this Resource Governor is that it allows you to monitor your resource usage using your metadata. You can also identify and set your workload priorities, and then you can associate your workload groups with different resources. Take a look at my diagram right down here. This RP 1, 2, and 3, those represent resource pools. With a resource pool, you can define how much resources something can consume. For example, you can set a max of 60% or a min of 20% of the system resources. So these three resource pools here, or however many you define, can have all different settings. For example, you might configure one to be geared towards OLTP environments and have another one geared towards data warehousing environments, maybe yet another one for ad hoc reporting. Now these work groups, or WG, we have 3 different work groups here. Once again, you can choose however many you want to configure. These will be mapped onto resource pools. When you're configuring your Resource Governor, one of the things that you're going to define is which work group gets mapped to which resource pool. You can actually have more than one workload group mapped to the same resource pool. Up at the top here, we have several different clients. These are client connections coming in, and they need to know which workload group to be assigned to. So we do that through this thing called a classifier, and all it is a user-defined function. Let's talk a little bit more about the concept of a resource pool. So the resource pool just represents the physical resources. So what you're going to do here is set min or max values for either the CPU or the memory, And what you're going to do is add up the min values for all of your resource pools. Make sure that it does not exceed 100%. Your max values have to be somewhere between the min value and 100, obviously. Let's assume that we have two resource pools, and we've configured the max memory to be 80% on each of those. Well, if you take 80% plus 80%, that's 160%, which is not possible. You cannot consume 160% of the resources on the machine. And so that's where the effective max comes into play. I'll show you a diagram of this in just a moment to explain these concepts. Then we have the concept of the shared percent. The shared percent is the effective max of a resource pool minus the min percent. For each one of your resource pools, you're going to have the reserved settings for that particular pool, and then you're going to have the shared percent, which is shared by all of the different pools. Now there are two resource pools that already exist, and they're called internal and default. Internal is used by the internal engine. You cannot drop it, you cannot modify it, and you pretty much can just ignore that one. The default resource pool is always present. You cannot drop it, but you can modify some of the values in there. So out of the box, if you haven't configured any resource pools, then all of those incoming connections are going to belong to the default pool. Let's take a look at some of our min and max settings here. So let's assume that we're configuring two new resource pools. As I mentioned, we already have our internal and our default pool. And by default, both of these have a min value of 0 and a max value of 100. If you want to configure the default, you can change these settings if you want to. So let's make some assumptions here that we haven't touched the default pool at all. And let's also make the assumption that pool 1 has a min memory setting of 40 and a max memory setting of 100. Let's also assume that pool 2 has a min memory setting of 20 and a max of 100. If we're going to calculate the effective max setting, we pretty much just ignore the setting for the internal pool, and what we want to do is for each one of these determine the effective max. So as I mentioned, the effective max is the lesser of these two values. It's going to be the lesser of the configured max, so 100, or 100 minus the sum of the other pool mins. In other words, 40 plus 20 is 60, 100 minus 60 is 40, so the effective max right here is 40. When we take the effective max for pool 1, we're going to add 0 plus 20. Okay, so that's 20. 100 minus 20 is 80. The lesser of 80 and 100 is 80. Then for pool 2 right here, we're going to take the min of 0 and 40, so take that sum, so that's 40. 100 minus 40 is 60, the lesser of 60 and 100 is 60. Now the shared percent is going to be the effective max minus the min. So in this case it's going to be 40, and here it's going to be 40, and here it's going to be 40. Now let's assume that we add one more pool. So we'll call this pool 3. And let's say that the setting is 10 and 80. So we need to do some recalculations here for the effective and shared. So I'm just going to erase this. Okay, let's do our recalculations here. So we're going to take 100 minus the sum of 40, 20, and 10. So that's 70. So that's going to be 30. And then we take 0 plus 20 plus 10, so that's 30. 100 minus 30 is 70. And then we're going to take 0 plus 40 plus 10, that's 50. 100 minus 50 is 50. And then for this guy right here, we're going to add up 0, 40, and 20. That gives us 60. 100 minus 60 is 40. The lesser of 40 and 80 is 40. So for our shared right here, it's going to be the effective max minus the min. So that's 30, 30. So you'll see how the shared is going to be all the same. Let's take a look at our workload groups. Our workload group is essentially just a container for session requests with similar resource needs. So when the client connections come in, we're going to have some kind of classification criteria that's determined by a user-defined function, and that's then going to assign it to the workload group. So within a workload group, this allows for aggregate resource consumption monitoring, which I'll show you in just a moment. Then your groups are going to be assigned to your resource pools. Let's take a look at the DDL statements that need to be issued to make these changes. If we want to create a resource pool, we say create resource pool and give it a name. Then you can say with, and you specify which settings you want to set. So here I'm specifying a min CPU % of 40, and I'm not setting a max. So that will default to 100. Anytime we make changes, we want to say alter resource governor reconfigure. In this second statement right down here, we have create workload group. We're giving it a logical name, call it anything you want, and we specify which resource pool we're using. So here it's using big pool. So essentially this is binding the ad hoc reports workload group to the big pool resource. Then we have an alter workload group ad hoc reports, and we're setting this back to the default. So I'm just showing you how you can change the resource pool that a workload group is associated with. If you want to drop a resource pool, you simply say drop resource pool and then the name. Now, this will not be possible if there are any workload groups associated with it. And also remember that you're not allowed to drop either the internal or the default resource pools. For you to issue any of these statements, it's going to require that you have the control server permission. If you want to dig around in the data dictionary to see which resource pools and workload groups exist, and then you can do a select star from sys.dm_resource, and you'll see we have these different views here. We have resource configuration, we have resource pools and workload groups. I'm interested in the governor resource pools. Let's execute this, and you'll see that right now we just have internal and default. If I want to look at my workload groups, I'll do a select star from sys.dm resource workload groups. Let me just execute that real quick. So we just have these guys right here. Let's create our new resource pool. So I'll say create resource pool. Let's call it pool 1. And we're going to say that it has a min CPU % equals 30. And let's also create a workload group. We'll call it group 1 using pool 1. Now whenever you make these kind of changes, make sure that you always say alter resource governor reconfigure. Otherwise it doesn't see the changes. Let's make sure to put our parentheses around here. Okay, we'll execute that. And then we'll execute this workload group. And then make sure that our changes stick. Okay, looks great. So now if we look at our resource pools again, you'll see that we have this pool right here. And if we look at our workload groups, you'll see we have group 1 right here. So you have these incoming client requests. How do you determine which group they belong to? Well, you're going to have to provide a function to determine that. Let's open up a new window here. And we'll just say use master. And what we're going to do here is create a table that's going to contain some entries. Basically, we want to group our different sessions by what time they're logging in. In other words, if somebody logs in between 7 a.m. and 9 p.m., maybe they'll belong to a particular workload group. Outside of that time, they might belong to a different workload group. So we're going to create this table that contains that information. So all we're doing is creating the table structure. Now the next thing we're going to do is just insert a record into there. So here we're going to insert into our table. Group 1 is going to be used between 7 a.m. and 9 p.m. Looks great. Now the next thing we want to do is create our own function that's going to determine which session it belongs to. So I'm going to go ahead and create my function right here. Let me move this down a little bit. And really you can call your function anything you want. After we create the function, you're then going to register it with the resource governor. So I'm calling mine my classifier. It returns a sysname. We have to say with schema binding, otherwise it will not compile. And here I'm just declaring two variables. One is going to be the group name, the other is going to be the login time. We're determining what time somebody logged in. Okay, so what we're doing here is we are taking our login time, we're getting the current date and converting it to a time. Then we are performing this select statement right here. So if I move this over a little bit, you can see the whole thing. The select statement is grabbing information from my table called classification times, and we're just setting our variable right here. Okay, so now we have an if statement. If the group name is not null, then we're going to return the group name. Otherwise, we're going to return default. In other words, use the default workload group. Let's execute this. And that completed successfully. As I mentioned, our next step is to register this with the resource governor. So let's just go in here. And here's our classifier function, alter resource governor with classifier function equals. And here's the name of our function, and then make sure we say reconfigure. So let's just highlight those two lines and execute it. So now whenever a session is started, it's going to call that function and determine which resource workload group to enter into. As far as gathering performance information regarding resource governor, there's a couple things you can do here. There are two significant performance counters that you want to pay attention to. One is the SQL Server workload group stats, and some important columns on there are the number of queued requests, active requests, as well as CPU usage percent. So that's for the workload group stats. And then there's another performance counter for SQL Server resource pool stats. So important ones there are CPU usage percentage, as well as used memory and max memory. So what you could do is divide the used by the max, multiply that by 100, and that will tell you whether you're hitting max memory or not. So you take these performance counters and plug them into your custom performance counters like we did earlier in this nugget. Let's review what we learned in this nugget. We first of all looked at the built-in performance counter that you can look at through your management data warehouse. There are three built-in reports. One is for server activity, the other is for disk usage, and also query stats. You can also create your own custom data collection. To find the full list of performance counters, simply go to the MSDN books online. You can see the full list there. Most likely you'll be looking for things such as full table scans, log growth, user connections and transactions, as well as lock requests or deadlocks. Make sure that if you create your own custom data collection that you store it in the MSDB database. We also looked at Resource Governor. Remember, the Resource Governor is used to avoid things such as out-of-control queries and to organize your workloads into priorities. With our Resource Governor, you're going to create one or more workload groups. Out of the box, there's already the internal and the default workload group. And you're going to use your own function and register it with the Resource Governor to assign sessions to various workload groups. Those workload groups will be assigned to resource pools which define the max and min CPU usage as well as memory usage. Then the last thing we looked at was monitoring. We had those two performance counters that we were talking about, and you can integrate those in with your custom data collections. Well, I hope this has been informative, and I'd like to thank you for viewing.